Okay, class, we're about to start lesson 3, and this is fraction basics. It says, basically, I'm going to jump over to the problem set, and I will explain how to do the fractions as we go through the problem set. It says, practice 3A, write a proper fraction for the shaded portion of each figure. Now, you need to know the difference between what a proper fraction is and an improper fraction. A proper fraction is basically this here. A fraction that the numerator, well, let me give you a fraction here. Let's say we had 3/5. Okay, first of all, the top value is called the numerator. The bottom value is called the denominator. Now, we also call this, if we're not talking mathematics, we call it the top and we also call it the bottom. Okay, so with that being said, a proper fraction is when your numerator, let me write down proper fraction, is the numerator or the top is smaller than the denominator, your bottom. Now we know the one exception is 0. So this works with any other numbers except 0. So the numerator top is smaller than the denominator, the bottom. That's the proper fraction. The next thing we will have is an improper fraction. Is when the numerator, the top, is the same or larger than the denominator, bottom, except 0. That's the one exception to both of these, for the proper fraction and the improper fraction. Now, it says here for A, write a proper fraction for the shaded portion of each figure. Now, I cannot draw the shaded figure, but I'm going to do a representation of it, because if I try and shade these figures in, that's going to take up my marker. And I want to be able to use my marker for more than just one lesson. So I'm just going to draw a squiggly line in here, which lets you know that these three are shaded. It represents from problem number 1. So the first thing you would do is count how many you have in this figure. I'm saying shaded and unshaded. It's 1, 2, 3, 4, 5. So when you write this as a fraction, the bottom is all of it. The bottom of the fraction is the total amount in the one figure. So it's 5. The numerator is what they're asking you to find, which happens to be the shaded portion here. It's 3 that's shaded, so 3 would be your numerator. And that is your final answer for number 1. Now, number 3. Now, you can see this on the screen here. We have 3 on the inside. So 3 would be your denominator. And we have 2 shaded. So it'd be 2/3. Okay, now let me do problem number 2, because 2 is a little different. We have 4 total value. We have 4 total. We have 2 shaded. So it'd be 2/4. However, we do run into a situation that is going to come later, but I'm going to show you this now. 2 and 4 both has 2 in common. Whenever you could divide both values by the same number to make the value look smaller, you're supposed to do that. That is what we call simplifying a fraction. So we would divide the numerator and denominator by the same value. 2 divided by 2 is 1, 4 divided by 2 is 2. So our final answer here would be 1/2. It's half of the figure. Okay, now we look down here, problem number 4. Now, number 4, it says write an improper fraction and a mixed number for the shaded portion of each figure. So we look here, you notice we have more than one figure here, but they're all cut the same. And I'm not talking about some shaded, some not. I'm just saying it's 3 in each. So your denominator, so first of all, we count how many wholly shaded ones we have. We have 2 that's wholly shaded. So that would be your whole number. Your fraction would be the ones that is not wholly shaded, but first we count how many is inside of one of them. It's 3. So your denominator would be 3. Your numerator is what's left of the shaded. It's only one part left of the shaded, so it'd be 1/3. Because remember, these two were fully shaded. That's how we got this whole number 2. And then we have one left over, which would be 1/3. Now, when I taught this in class, I started this off a little different. So I'm going to write under number 4 how I actually did it in class. What I did in class, I counted how many one of them had, which would be 3. And then I counted how many was shaded. We had 1, 2, 3, 4, 5, 6, 7. So I wrote 7/3. So that's how much is the fractional portion. But we wanted to write this as a mixed number. And we see we have two of them wholly shaded. Our denominator is still 3. And we have one shaded portion left. So a 7/3 is equal to 2 1/3. All right, number 5. Number 5. Let's try it the way how I did it in class. We have 2 shaded. We have 2 that's total inside of the figure. Now we count all the shaded portion, 2, 4, 6, 7. So that'll be 7/2. But we want to write this as a mixed number. So we count how many that's totally shaded is 3. Our denominator is still 2. And we have one shaded portion left over. So that'd be 3 1/2. Now for number 6, we count inside 1, we have 4. Count how many shaded, we have 4, 8, 12. That'll be 15. So we have 15/4. And then that's equal to, we have 3 that's fully shaded. Our denominator is still 4. And we have 3 shaded portion left over. So that'll be 3 3/4. Now we look here at problems 7 through 16. It says write improper fractions as mixed numbers and mixed numbers as improper fractions. Okay, so let's take a look at number 7. We have 17/3. So we want to change this improper fraction because we notice the top is larger than the bottom, so it's an improper fraction. We want to write this as a mixed number. To write this as a mixed number, we would change this to division. We know 17/3 is the same thing as saying 17 divided by 3, which is the same thing as saying 3 in the 17. So fractions is just another extension of division. So we know 3 goes into 17 5 times. 5 times 3 is 15. 17 minus 15 is 2. So we have 5 remainder 2. Okay? So our final answer would be 5. This number in front of the remainder is your whole number. So we have 5. Our denominator stays the same. Our denominator was 3. So the denominator stays 3. And our remainder becomes the numerator of the fraction. So our answer here is 5 2/3 for number 7. Now, number 7. So now we're going to do another one. Let me jump to problem number 13. We have 43 over 9. So we know that's 43 divided by 9, which is 9 into 43. 9 doesn't go into 4, but it goes into 43 4 times. 4 times 9 is 36. We could borrow 1 from this 4 to make it 3. This 3 becomes 13. 13 minus 6 is 7. And 3 minus 3 is 0. So we have 4 remainder 7. So again, this number in front of the remainder is our whole number. Our denominator stays 9. And our numerator is the remainder. So it's 4 7/9. Okay, now there is a problem that might be a little tricky. And it's not tricky because you know it, but it's tricky because we're working on something new and it will have you believing that it's something totally different than what it is. Like problem number 9. Problem number 9, we have 24 over 6. Now remember, that's still the same as 24 divided by 6 or 6 into 24. 6 doesn't go into 2, but 6 goes into 24 4 times. 4 times 6 is 24. We have remainder of 0, so our final answer still would just be 4. It won't be a mixed number. It'll just be a whole number. So you got to be conscious of that. You still have to apply the rules that you have used before on other problems. So now we go here to change a mixed number to an improper fraction. Okay, so with that being said, let's look at number 8. Number 8, we had 3 3/5. Okay, so I'm going to write this out the long way first. Okay, first of all, your denominator stays the same. Okay, now your numerator goes like this. You would take the whole number 3 times the denominator. So this times this. 3 times 5, and then you would add the numerator. So this will end up being 15 plus 3 over 5, which is 18 over 5. And that is our final answer, because this is what they wanted us to write. Okay, now that would take care of number 8. Now we're going to go to number 10. I'm going to do a couple more of these so you could get into practice. 5 2/9. Again, we will multiply, we'll keep the denominator the same at 9. We'll take the whole number times the denominator plus the numerator. So this will be 45 plus 2 over 9, which is 47 over 9. Okay, next. I think 16 will be the last one I would do from this portion. Problem 16. We have 5 7/10. So we will keep our denominator at 10. Numerator, we'll take the whole number times the denominator plus the numerator. So it'll be 50 plus 7 over 10, which is 57 over 10. Okay, now it says here for D, it says write an equal fraction with a given denominator. All right. Now, this is a little different. It's not bad, but it's a little different. So we look at 17. 17, we have 3/4 is equal to something over 16. So now we ask ourselves, we're supposed to ask ourselves, what number times 4 would give us 16? Because remember, we're going from this value to this value. So we have to ask ourselves, what number times 4 gives us 16? We know 4 times 4 is 16. So let me rewrite this because I didn't give myself enough room. So we had 3/4 equals blank over 16. Okay, so like I said, 4 times 4 is 16. But whatever we multiply the bottom by, we also must multiply the top by it. 4 times 4 is 16. 3 times 4 is 12. So we had 12/16, and we will leave it this way. Because remember, we're trying to find an equivalent fraction. Okay, now, moving on. So I'm going to rewrite that last problem because it's a little more we have to do with that problem. 3/4 is equal to blank over 16. And we did the multiplying by 4/4, which gave us 12/16. Okay, now, the one thing that I did do in class that I didn't do here, which I'm going to correct now, is this. I wrote this on the board. I had 5 times 1 is 6, 6 times 1 is, 5 times 1 is 5, and 6 times 1 is 6, and 7 times 1 is 7. Now, if you notice here, when we multiply, whenever we multiply by 1, the number remains the same. And it's the same thing with division. This would be 5, this would be 6, this also would be 7. Same thing with division. Now, with that in mind, since we notice that this doesn't change, watch what happens here. If I did 5 times 4/4, isn't 4/4 1? So that means that 5 times 4/4 is really just 5. 6 times 4/4 is really just 6. And 7 times, let me try another number, 3/3 is really just 7. It's the same concept as taking 100 pennies, 100 cents, and writing it as $1. Their value is the same even though they look different. And that is what's happening here. Even though 3/4 and 12/16 look different, they have the same value. But the reason we know they have the same value is because we multiply by a form of 1, which does not change the value. Okay, so now taking that, let's look at problem number 19. And I like to give myself space so you can see it. So we have 4/5, a little space here, and it's equal to blank over 60. So now we have to ask ourselves, 5 times what is 60? 5 times 12. So we have to multiply the top and bottom by 12. 12/12 is 1. So 5 times 12 is 60. 4 times 12 is 48. So it'll be 48/60. Next, we add 21. We have 6/25, and it's equal to, the denominator is 100. So we ask ourselves, 25 times what is 100? We know 25 times 4 is 100. So that'll be 4/4. So 25 times 4 is 100. 6 times 4 is 24. So that took care of those problems. Now, with E, we're going to do the opposite. It says reduce each fraction to lowest terms. So, for problem 22, and I'm still going to leave a little space, we have 21/28, and I'm going to put an equal sign here. Now we have to ask ourselves, is there a number that can be divided into 21 and 28? That number, yes, that number is 7. So we could divide both of these by 7/7. Now remember what we saw over here with division. If it's divided by 1, it's the same value. 7/7 is really 1. So your answer is going to have the same value. It's just going to look a little different. So 21 divided by 7 is 3. 28 divided by 7 is 4. So that's your answer for 22. Now we could jump on over to 25. 25, we have 26 over 30. So we ask ourselves, what does 26 and 30 have in common? Now, if you're looking at this number and can't think of anything, remember 26 and 30 are both even numbers. So whenever you have even numbers, you could always divide by 2. So you could divide both of these by 2 to make the number a little smaller to see if there's anything else you could pull out. 26 divided by 2 is 13. 30 divided by 2 is 15. So 13 over 15 is your final answer. Now for 26, we have 60 over 90. Now, 60 over 90, one thing that we could see real fast is that first of all, they're both even, so we could do 2. But because both of these end in 0, we could actually divide both by 10. 60 divided by 10 is 6. 90 divided by 10 is 9. But we notice here 6 and 9 still have something in common, which is 3. So we keep on dividing until we get it down where they only have 1 in common. 6 divided by 3 is 2. 9 divided by 3 is 3. So that's it. 2 and 3 only has 1 in common. Okay, now for problem 27 and 28, which is the last of this section, it says 18 out of every 24 people surveyed say they went to at least one movie in December. What fraction of the people surveyed went to at least one movie in December? So they said 18 out of 24. So 18 out of 24, we find out what they have in common. Let's try 6. Divided by 6 over 6. 18 divided by 6 is 3. 24 divided by 6 is 4. So your answer would be 3/4, which is A. Problem 28. Which of the following fractions equals, it looks like it says 2/5. So what we would have to do is this here. You notice that all of them have a denominator of 100. So we'll do 2/5, and then we want it to equal to the denominator to be 100. So we ask ourselves, 5 times what is 100? We know 5 times 20 is 100. So we'll multiply this by 20 over 20. 5 times 20 is 100. 2 times 20 is 40. So it's 40 over 100, which is C. And that concludes this lesson 3. It will be put up on YouTube. So have a wonderful day.